Hello everyone, I am Balaji Rao. Welcome to BR Max class. We completed 3 exercises in matrices chapter class 12. Now we are in 4th exercise. Before starting this 4th exercise, in 4th exercise all the problems are of same type. In all the problems what they'll ask, find the inverse of a matrix by using elementary operations. Finding inverse of a matrix by using elementary operations is not so easy. Many students, they feel difficult to find inverse of a matrix by using elementary transformations. But I used a trick. By using that trick, you can easily find inverse of a matrix by using elementary transformations. While finding inverse of a matrix, we will use elementary row operations. Once you got an idea that how to write these operations as per the requirements. Once you are able to write the row operations as per the requirements, these problems are very easy. Please watch the video full so that you will get clear clarity, and practice is the key in this exercise. How many problems you will do, that much perfection you will get. Before going to start this video, please drop a like for this video and share this video with your friends. In case if you are not yet subscribed, subscribe now. So let's begin the class.
In this class, we will learn the definition of invertible matrix and we will learn the proof of AB whole inverse equal to B inverse into A inverse. Okay, first we will learn the definition of invertible matrices. Let A is a square matrix of order M and B is another square matrix of same order. That means B is also square matrix of order M by M such that AB equal to BA equal to I. This is important. A into B, AB equal to BA equal to I. Then B is called inverse of matrix A. Try to understand. A is a square matrix of order M and B is another square matrix of same order such that when AB equal to BA equal to I, then this B is called inverse of matrix A, which is denoted by, look here, what is B? B is called inverse of A. Inverse of A is denoted like this. Inverse of A is denoted like this. What we are saying here, B is called inverse of A. So, which is denoted like this. B is called inverse of A. We say that A inverse equal to B. Here, one important note point. Here you see AB equal to BA equal to I. Then what we know? We know that B is called inverse of A. In place of B, what I can write? I can write A inverse. So what I will do in this equation, in place of B, you write A inverse. So this is one of the important property. From now onwards, wherever you see A into A inverse, we can directly write its answer as I. A inverse into A is also I. Here, another important point. When AB equal to BA equal to I, then B is called inverse of matrix A. Similarly, A is also called inverse of a matrix B because you can observe here BA equal to AB equal to I. What I am trying to say, if B is inverse of matrix A, then A is also inverse of a matrix B. Not only A into A inverse, B into B inverse is I. B inverse into B also I. Now we are going to learn theorem related to invertible matrices. You observe this theorem statement. A comma B are invertible matrices. That means inverse of A exists and inverse of B also exists. A and B are invertible matrices of same order. Then AB whole inverse equal to B inverse into A inverse. I want to prove this statement. Just now from the definition, we learned this. AB equal to BA equal to I. Then B is called inverse of matrix A. This is what we learned. Here you observe one more thing. Something matrices we found like this. PQ equal to QP equal to I. Then this Q is called inverse of P, which is denoted like this. Q is called inverse of P. So to prove this statement AB whole inverse equal to B inverse into A inverse, what I'll do, I'll prove this matrix into this matrix. It is just like, imagine like AB equal to, you look here, BA equal to I. Then what I can say? I can say that B inverse A inverse is called, B inverse A inverse is called inverse of matrix AB, which is denoted like this. I hope you are understanding. When AB equal to BA equal to I, then B is called inverse of AB. Similarly, AB into B inverse into A inverse equal to B inverse into A inverse into AB equal to I. If I prove this, what I can say? I can say that B inverse A inverse is called inverse of AB. So to prove this result, AB whole inverse equal to B inverse into A inverse, what I'll do, first I'll consider AB into B inverse A inverse and I'll prove that equal to I. Similarly, I'll consider B inverse A inverse into AB and I'll prove that equal to I. When I can prove this statement, then I can conclude that B inverse A inverse is nothing but inverse of AB. First, you consider A and B are invertible matrices. Now you observe I considered AB into B inverse A inverse. I'll simplify that and I'll prove that this is nothing but I. Okay. So here you need to know one thing. With respect to matrix multiplication, associative law holds good. AB into C can be written as A into BC, right? This is associative property with respect to multiplication. Here what I'll do, you observe this is AB into, I'll consider this whole thing as C. It is looking like AB into C. AB into C can be written as A into BC. Please try to understand. So what this can be written as? This can be written as A into BC. BC means here B. I consider this whole thing as C. That is AB into C written as A into BC. Just now from the definition of invertible matrices, we know that B into B inverse is I. B into B inverse is I. So what this will become? B into B inverse is I. I into A inverse. Okay. Here A inverse is a matrix. We learn from the properties of a product of matrices. AI equal to IA equal to is what? Is A. We know this property. See here, I into A. I into A is what? A. So here I into A inverse is what? That is A inverse only. So first I'll write A into I into A inverse is A inverse only. Right? So as they given A is invertible matrices, A into A inverse is what? We just learned from the definition of invertible matrices. A into A inverse is I. What happened? I considered AB into B inverse A inverse. I got it as I. Now I'll consider this and I'll prove this is I so that I can conclude. Okay. You observe this. I considered this part B inverse A inverse into AB. Here also I'll go with the same procedure. A, B. AB into C. AB into C can be written as A into BC as associative property holds good. So this can be written as B inverse into A inverse into AB. I hope you are understanding. You treat this as AB into C, which can be written as A into BC. Okay. This equal to B inverse into, we know that A inverse into A is I. Okay. So A inverse into A is I into B. So that equal to B inverse into I into B as per this property. I into A is A, I into B is B, I into C is C, like that. I into B is B. Okay, just now we learned from the definition of invertible matrices, B inverse into B is I. As the B is a invertible matrices, B into B inverse can be written as I. So I'll conclude here. What I proved that, so what we proved here? We proved that AB into B inverse A inverse equal to B inverse A inverse into AB equal to I. From the definition of invertible matrices, what I can conclude here? I can say that B inverse A inverse is called inverse of AB, which is denoted like this. Inverse of AB. So finally what we got? We got that AB whole inverse equal to B inverse into A inverse. I hope you understand this class. If you like this video, please drop a like. If you have any doubts, comment below. In case if you are not yet subscribed to my channel, subscribe now and share this video with your friends. In this class, we will learn how to find inverse of a matrix by using elementary transformations. First, I'll consider given matrix as A. I considered given matrix as A. Now, I need to find A inverse. How? By using elementary transformations. We have some standard procedure to find inverse of given matrix by using elementary transformations. In that, first step is I'll consider A equal to IA. This is the fixed step for every problem of this type. We know that IA equal to AI equal to A. This is the property which always holds good. So I can consider like this. Now what I'll do, in place of this A, I'll write the matrix A. See, in place of A, I written this matrix A. Now, what is I? I means identity matrix. So in place of I, I'll write identity matrix. We know identity matrix is 1, 0, 0, 1. And here important thing is, this A we will write as it is. In place of this A, we don't write matrix A. Okay. So first, you consider given matrix as A, afterwards you write A equal to IA, and in place of A, you write matrix A, in place of I, you write identity matrix, A, you keep it as it is. From now onwards, what I'll explain, you please follow the things as it is to get the answer easily. It is not compulsory, you should follow what method I am saying to get the answer. In different methods also you may get the answer, but if you follow the method what I am saying, then you will get the answer easily. Okay, now what is my intention? You observe this matrix. I want to convert this matrix into identity matrix by using U rule. You know identity matrix means 1, 0, 0, 1. This is the identity matrix. What I am saying here, I want to convert this matrix into identity matrix by using U rule. U rule means first I'll make this element 1. Please observe here. I'll make this element 1. Later I'll come to this. I'll make this element 0. I do not go for this element. Try to understand. U rule. First I'll make first element 1. Immediately below element I'll make 0. After that I'll come here and I'll make this element 1. And then I'll come here. I'll make this element 0. This you will understand in the procedure. What I am trying to do, I am trying to convert this matrix into identity matrix by using U rule. Okay, you observe here. What is this? In this place here 1 is there. But here 1 is not there. What I am trying to convert this matrix into identity matrix. In identity matrix, first element must be 1. But here 1 is not there. So you should make this element 1. How? To make any element 1, particularly in this model, you just multiply complete row with 1 by 2 or just divide with 2. You observe this. This is the element I want to convert into 1. This is in which row? This is in first row. So I'll write like this. First row R1. How R1 changes? I want to make this element 1. How I can make this element 1? I'll divide this complete row with 2. Which is nothing but I'll multiply row 1 with 1 by 2. Suppose here 3 is there. You need to make this into 1. You just multiply with 1 by 3. No other thing. You can make in another methods also. But if you follow this procedure, you will get the things very easily. Okay. Now what I'll do, I'll apply this elementary operation. All the elements of first row, I'll multiply with 1 by 2. Okay, you observe this is the first row, na? You multiply 1 by 2 into 2. 1 by 2 into 2 is what? 1. Okay, now 1 by 2 into 1. 1 by 2 into 1 is 1 by 2. Okay, first row equal to. Here the thing is, this operation is applicable for this matrix also, for the first row. Okay, 1 by 2 into 1. 1 by 2 into 1 is 1 by 2. Okay, next 1 by 2 into 0. 1 by 2 into 0 is 0. I hope you are understanding. Is there any change in row 2? No, there is no change in row 2. So I'll write row 2 as usual. 1, 1, 0, 1 into A. Okay, good. Now please observe what is my intention. I want to convert this into identity matrix. In that procedure, I am making this element 1. You observe here, I got 1 here. Okay, now immediately as per your rule, you come here. Don't go for this element. You come here. What element is there here? Here 0 is there. So what I want 0 here. In this place, I want 0. How I'll get 0 here? Very simple. When 1 is there here, making this element 0 is dead easy. See here, I want to make this element 0. 1 minus 1. It's simple. So what I'll do, I want to convert this element into 0. This element is in which row? This element is in second row. So R2. R2 changes to what row you written here, immediately you write the same thing. Here you written R2 means you don't get R3, R1 here. What you written here, write the same thing. R2. 1 minus 1. Minus. This 1 is in first row. R2 minus R1. Writing this operation is very easy. Little bit of practice is needed. That's it. Now you observe this. Any change in row 1? No. Change is there in row 2 only. So I'll write row 1 as usual. 1 by 2 equal to row 1 as usual 1 by 2 0, okay, into A. Now change is there in R2. How R2 changes? R2 minus R1. 1 minus 1. This is 0, right? Okay. Now R2 minus R1. You look here. This is R2. 1 minus 1 by 2. 1 minus 1 by 2 is what? 1 minus 1 by 2 is 1 by 2. Easy simplification only. 0 minus 1 by 2. Look here. R2 minus R1. This second row. R2. 0 minus 1 by 2. 0 minus 1 by 2 is minus 1 by 2. Okay. 1 minus 0. 1 minus 0 is 1. I hope you are understanding. So, what happening? I am trying to convert this into identity matrix by using U rule. You observe here. What I got here? I got 0. That means this is also over. Now, where to go? You come to this element. This element. You need 1 here. You look here. Here, the element 1 is there? No. You need to make this element 1. How to make this element 1? What operation I am trying to say, you try to understand that and you follow same method for all other problems also. I need 1 here. How I'll get 1? If I multiply with 2. If I multiply with 2, 2 into 1 by 2, 2 will get cancelled. I'll get 1 here. I hope you are understanding. What I'll do, this complete row, I'll multiply with 2. This is in which row? This is in second row. So I'll write like this, R2. R2 changes to what I want here? I want 1. How I'll get 1 here? If I multiply with 2, 2 into 1 by 2 is 1 only. That's why I'm writing like this, 2 into R2. Okay. Now you see, apply the same operation, what you will get? This is R2 changes there. Any change in R1? No change in R1. So what I'll do, I'll write 1 by 2. Okay. I'm writing R1 as it is because there is no change in R1. 1 by 2, 0. Okay, into A. Now, is there any change in R2? Yes, all the elements of R2 are multiplied with 2. 2 into 0, that is 0. Okay, now 2 into 1 by 2. 2 into 1 by 2 is 1. Okay, now 2 into minus 1 by 2. 2 into minus 1 by 2 is minus 1. Okay, now 2 into 1. 2 into 1 is 2. Okay, things are going very nicely here. What I am trying for? I am trying to get 1 here. We got 1 here or not? Yes. What I am trying? I am trying to get this matrix as identity matrix. In that process, I am following this U rule. First, I made this element 1. Next, I made this element 0. Next, I made this element 1. Now, you come to this. What I am trying for now? I want to make this element 0. See here, I want to make this element 0. When 1 is there here, making this element 0 is very easy. How? Here 1 by 2 is there na? 1 by 2 minus 1 by 2. Here I need 1 by 2. I want to make this element 0. This is in which row? Row 1. So I'll write like this, R1. What operation you written? What row you written? Write the same row, 1 by 2. What element I want here? I want 0 here. To make this element 0, 1 by 2 minus 1 by 2. Here 1 by 2 is there, it is easy. So what I'll do, second row, I'll multiply with 1 by 2. Please try to understand. For second row, when I multiply with 1 by 2, 1 by 2 into 1 is 1 by 2. Then 1 by 2 minus 1 by 2 will become 0. This is easy step only. Little bit of practice is needed. That's it. Why I written this step? Because I want 0 in this place. Right? Okay. Now, any change in R1? Yes, change is there in R1. What is that change? R1 minus 1 by 2 into R2. Okay, R1 means what element here? 1 minus 1 by 2 into R2. R2 means what element is there here? 1 by 2 into 0. So this is 1 minus 1 by 2 into 0 is 0. 1 minus 0 is what? That is 1 only. So this element 1 only. Okay. Now R1 means 1 by 2 minus 1 by 2 into the element which is present in R2. What is the element present in R2? That is 1. Okay. 1 by 2 minus 1 by 2 is what? That is 0. It is simple. Almost this problem is over. Okay. That equal to R1 changes to R1. What element is there here? The element 1 by 2 is there. Okay. 1 by 2 minus 1 by 2 into the element present in R2. What is the element present in R2? That is minus 1. Okay. This is 1 by 2. This minus of minus will become plus. 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 is 2 by 2. That is nothing but 1. So what you will get here? Here you will get 1. Okay. Now R1. What is R1? Here this element. Look here. R1 0 minus 1 by 2 into corresponding element in second row. That is 2. Okay. So what you are getting here? 0 minus this 2 will get cancelled. 0 minus 1, that is nothing but minus 1. So you are getting minus 1 here. I hope you are understanding. Right, into A. So any change in row 2? No change in R2. So we will write row 2 as usual, minus 1. By what intention we started this problem? I want to make this into identity matrix. You can observe here, I got the identity matrix. To make this matrix into identity matrix, I followed the U rule. That is important. So once you got this is identity matrix, whatever the matrix present here, that is known as inverse of the given matrix. Therefore 1 minus 1 minus 1 2. I hope you are understanding. So in this way, we can calculate inverse of a given matrix by using elementary transformations. It is all about little bit of practice. Now, I'll do one more problem of same type so that you will get more clarity on these elementary transformations. Okay, you observe the second question. Using elementary transformations, find the inverse of this matrix. I want to find inverse of this matrix. Okay, so first what I did, I considered the given matrix as A. That means I need to calculate A inverse. What is the first step? In all these problems, first step is A equal to IA. What is this? This is the property which is always true. IA equal to A. Now in place of A, you write the given matrix A. What is the given matrix? 1, minus 1, 2, 3 equal to I. I means identity matrix. In place of I, you write identity matrix 1, 0, 0, 1 into. Here is the trick. You write this A as it is. Don't write the matrix A. Now, I want to convert this matrix into identity matrix by using U rule. What is U rule? I'll follow this order like, see, first I'll make this element 1. Next, I'll come down and I'll make this element 0. And I'll go here, I'll make this element 1, and I'll go here, I'll make this element 0. That is U rule. Just to remember, I am saying it is U rule. Okay. Okay. Now, first thing, I want 1 at this place. You observe the question. Luckily, here 1 is there. So, no need to worry. This step is already over. Feel happy and come down. And you want to make this element 0. You look here, this element is not 0. But when 1 is there here, making this element 0 is very easy. This element is in which row? This element is in second row. Okay, you write R2 changes to what row you written? You write the same row, R2. Here 2 is there. If 2 is present here, 2 minus 2, this will become 0 easily. R2 means the element 2 is there, minus. Here I need 2. How I'll get 2 here? You multiply this number with 2. 2 into 1 is 2. R2. I want to make this element 0. To get 0, 2 minus 2. I need 2 here. So what I'll do? 2 into R1. I hope you are understanding. Right. If I apply this operation, I can make this element 0 very easily. Actually, this is very easy step. Little bit of practice is needed. Okay. Any change is there in R1? You look here. No change in R1. So you write R1 as it is. 1 minus 1, 1, 0 into the matrix A. What I did, I written R1 as it is. Now R2 changes there? Yes, R2 changes there. What is that? R2 minus 2 into R1. You look here, R2, that is 2, minus 2 into R1. What element is there in R1? 1, right? This is nothing but 0. So in this place, you will get 0. Okay, now look this element, R2. R2 means what here? 3. R2, 3 minus 2 times, look here, minus 2 times of R1. R1, what element is there? That element is minus 1. So 3 minus of minus plus, 3 plus 2 is what? 5. So what you will get here? You will get 5. Okay, good. Now this here also you need to complete R2, you need to apply this operation. R2 is 0 minus 2 times of R1. R1 is what? 1. So what you will get? This is nothing but minus 2. So you write minus 2, right? Now R2 means 1 minus 2 times of R1. R1 is 0. This is nothing but 1. Okay, right. Now you observe, I want to make this element 0. I got 0 here. You observe. So this is done. This is over. Now as per your rule, you come here and you need 1 at this point. You need 1 here, right? How to make this element 1? So many methods are there, but if you follow this method, you will get answer easily. What I'll do, to get 1 here, I'll multiply this complete row with 1 by 5. 1 by 5 into 5 is what? That is 1 only now. So this is in which row? This is in second row. R2 changes to, what I'll do, this complete row, I'll multiply with 1 by 5. 1 by 5 into R2. Now, any change is there in R1? No change in R1. So what you will do? You write R1 as it is. R1 as it is. 1, 0 into A. Any change is there in R2? Yes. What is the change? All the elements of second row multiply with 1 by 5. 1 by 5 into 0, that is 0. 1 by 5 into 5, that is 1. Okay. 1 by 5 into minus 2. 1 by 5 into minus 2, that is minus 2 divided by 5. All the elements of second row you multiply with 1 by 5. 1 by 5 into 1, that is 1 by 5. Okay, almost over. See here, I want at this place 1. I got 1 here. What I am trying for? I am trying to make this matrix into identity matrix. In that procedure, I am using this U rule. Here I got 1. This 0 is also over. 1 is also over. Now what I need here? I need 0 at this place. Look here, come here. I want in this place 0. Okay, how I'll get 0 in this place? When 1 is there here, making this 0 is very easy. Here minus 1 is there now. You add with this element. Minus 1 plus 1 is what? 0 now. So what I'll do? I want to make this element 0. This is in which row? This is in first row. R1 changes to R1 plus R2. I hope you are understanding. This is easy only. Little bit of practice is needed. That's it. Okay. Any change in R1 is there? Yes. Change in R1 is there. We are adding R1 and R2. Okay. 1 plus 0. 1 plus 0 is 1. Minus 1 plus 1. Minus 1 plus 1 is 0. Okay. That equal to, in this also, here also you add 1 R1 plus R2 na. Here R1 means what is there? 1 plus R2 means what is there? Minus 2 by 5. See, plus of minus is minus. This is what? 5 minus 2. That is 3 by 5. Okay. So what you are getting here? You are getting 3 by 5. Okay. Now this one. R1 plus R2. R1 plus 0 is there. Plus R2 plus 1 by 5 is there. 0 plus 1 by 5 is 1 by 5. So you got 1 by 5 here. Okay. Into A. Now R2 elements as usual. 0, 1, minus 2 by 5, 1 by 5. So you observe here, we got the identity matrix. Once we got identity matrix here, the problem is over. Whatever the matrix is present here, that is inverse of the given matrix. So what is the conclusion? Therefore, I can write A inverse. What is A inverse? A inverse is 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. I hope you understand this class. If you want me to do one more video on this finding inverse by using elementary transformations, please comment below. And Guys, if you like this video, please drop a like and share this video with your friends. If you are not yet subscribed to my channel, please subscribe now.
We need to find inverse of this matrix by using elementary transformations. So what I'll do, first I'll take given matrix as A. You take given matrix as A. What is A? The matrix A is 3, 1, 5, 2. What you want to calculate? You want to calculate inverse of this matrix. To calculate inverse of this matrix, what is the first step we'll write? We'll write A equal to IA. This is the first step in all the problems in this exercise. Okay. Now I'll write matrix A. What is matrix A? 3, 1, 5, 2. Okay. And identity matrix. What is identity matrix? Identity matrix is 1, 0, 0, 1 into A. Into A. This A you write as it is, but don't write matrix A. Okay. Now to find inverse of this matrix, what we'll do? We will convert this matrix into unit matrix, identity matrix. What is identity matrix? Identity matrix is 1, 0, 0, 1. Right? I want to convert this matrix into unit matrix by using elementary transformations, elementary row operations. Okay. So for that, to convert this matrix into unit matrix, we'll follow the U rule. What is that U rule? See here, you observe here, this is the U rule. What I'll do in this U rule, first I'll start from this place. Then I'll move to this place, right? And then I'll move to this place. And then I'll come to this place. By following this U rule, we'll convert this matrix into unit matrix. Okay. So to convert this matrix into unit matrix, in this place, first we need to get 1, right? So here, you see here in this place we want 1, but here 3 is there. I want 1 in this place. How to get 1? By using elementary row operations. Here 3 is there now. If I multiply 3 with 1 by 3, what happened? 3 will get cancelled, I will get 1. So basic idea is, I want to convert this into 1. So this is in first row, na? This is in first row. This complete first row, I'll multiply with 1 by 3. Why I am multiplying 1 by 3? Just to get 1 at this place. Okay. Now, all the elements of first row changes. How all the elements of first row changes? All the elements of first row I'll multiply with 1 by 3. All the elements of first row you multiply with 1 by 3. So let's see what you will get. R1 change is there, right? All the elements of first row changes. Okay. 3 into 1 by 3. All the elements of first row 1 by 3 into R1. All the elements of first row you multiply with 1 by 3. 1 by 3 into 3 is what? That is 1. Okay. Next, multiply this 1 by 3 into 1. 1 by 3 into 1 is 1 by 3. Okay. Next, 1 by 3 into 1, that is 1 by 3. 1 into 1 by 3, that is 1 by 3. Okay. Now, 1 by 3 into 0, that is 0, equal to A. What happened? All the elements of first row I multiplied with 1 by 3, so I got this. In this, there is no change in R2. Change is there only in R1. So this R2 you write as it is here. Okay. R2 5, 2, 0, 1. Okay. Now, as we are following this U rule, our work is completed at this part. Now, you move to this place. And you observe here what I want at this place. I want 0. You observe here in this, you observe here I made this element 1. Now we are at this place. Please observe, we are at this place. What you want at this place? At this place you want 0. So here you need to get 0 here. How to get 0 here? Whenever you see 1 on the top of it, making this 5 0 is very easy. We can make this 5 as 0 by using elementary transformations with the help of this one. How? Very simple. I want 0 here. Na? How I will get 0? 5 minus 5. This is 5. I want 5 here. Then if I apply R2 minus R1, I will get 0 in this place. Right? You try to understand. To get 0 here, I want to use R2 minus R1. So R2 minus R1, if you want to get 0 here, it must be 5. This must be 5. So you need to get 5 here. So I'll use this operation. See, I want to change R2. I'll write here R2. I want to change R2. R2 changes as R2. See here, what operation you will write? You need to write the same thing here. R2 minus, in what you want 0 here, minus, how to get 5 here? How to get 5 here? You just multiply with 5. 5 times of R1. Writing this operation is crucial. If you understand how to write this operation, these problems are very easy. So why I written this operation? If I write this operation at this place, I will get 0. My intention is I want to get 0 at this place, right? Okay. Now apply that operation here. What you will get? R1 no change. So I'll write R1 as it is. 1 by 3, 1 by 3, 0. No change in R1. Change is there only in R2. Change is there only in R2. Okay. What operation I need to use? R2 minus 5R1. See here, this is in R2. Na? R2, 5 minus 5 times of R1. R1, what element is there? 1 is there. 5, you see this one. By seeing this, I am writing this operation. 5 minus 5 is what? 0. You will get 0 here. I hope you are understanding. Now come to this part. R2. R2, what is there here? 2. Minus 5 times of R1, what is there? 1 by 3. 5 into 1 by 3. I'll write 1. 2 minus 5 into 1 by 3. What you will get? This is nothing but 6 minus 5 by 3. That is 1 by 3. Simplify this. 6 minus 5 by 3. 6 minus 5 divided by 3. That is 1 by 3. Okay. So here what you will get? Here you will get 1 by 3. Right. Now come to this element. Okay. 0 minus 5 times of R1. That is 1 by 3. That is 0 minus 5 by 3. 0 minus 5 by 3 is what? That is minus 5 by 3. So you write minus 5 by 3. Now come to this element. R2, that is 1 minus 5 times of R1, 0 is there. That is 1 minus 0 is 1. So you will get 1 here. I want to convert this matrix into unit matrix. In that, I am at this part. You observe, I got 0 here. Now you move to this side, right? Here work is completed. We made this 0. Now you came to this part. You want to make this element 1. You see here, you want to make this element 1. Okay. How to make this element 1? See, very simple. Here 1 by 3 is there. Na? If I multiply with 3, then 3 will get cancelled. I'll get 1. This is the easiest operation to get 1 at this place. Okay. So what I'll do here, this is in R2. All the elements of R2, I'll multiply with 3. All the elements of R2, I'll multiply with 3. Why? Because I want 1 at this place. To get 1, I am using this operation. That's it. Okay. Now, there is no change in R1. You write R1 as it is. 1 by 3. Okay. Equal to 1 by 3, 0. No change in R1. That's why I written R1 as it is. Now, R2. Multiply all the element of R. What happened? Multiply all the elements of R2. Here R2. Multiply all the elements of R2 with 3. Okay. 3 into 0. What is that? 3 into 0 is 0. Next 3 into 1 by 3. Look here. 3 into 1 by 3. 3 into 1 by 3 is what? 1. Okay. Next 3 into minus 5 by 3. 3 into minus 5 by 3. That is minus 5. Minus 5. Next 3 into 1. That is 3 into A. Now you want to convert this into identity matrix. In that procedure, you can observe we want to make 1 at this spot. We got it. Now our work is completed at this place. Now you move to this part. You want 0 at this place. We can make this 0 very easily when 1 is there. We can make this element 0 with the help of elementary transformations by using this 1. How? Here 1 by 3 is there. Na? I want 1 by 3 here. 1 by 3 minus 1 by 3. How to get 1 by 3 here? You just multiply this row with 1 by 3. So this is simple only. You need to practice little bit. So what I'll do now? I'll use this R1. I want to get 0 here. To get 0 here, I'll use this separation. This is in first row. Now R1 changes as R1 minus. What you will write here? Same thing you will write here also. R1 minus. You want 1 by 3 at this place. Right? How you will get 1 by 3? Multiply this row with 1 by 3. 1 by 3 into R2. If you understand how to write these operations, these problems are nothing. Very easy. Okay. So, yes. Now, change is there in first row. R1 minus 1 by 3 into R2. R1 is 1 minus 1 by 3 into R2 is 0. 1 minus 1 by 3 into 0. Okay. What you will get? That is 1 only. Now, see this one. R1 1 by 3 minus 1 by 3 into an R2 1 is there. Right? What this will become? This will become 0. Right? This is 0. Now you got 0 at this spot. Good. That equal to R1. R1 changes as R1. R1 is what? 1 by 3 minus 1 by 3 into R2. In R2 what is there? Minus 5 is there. So what is this? 1 by 3 plus 5 by 3. That is what? That is 6 by 3. 6 by 3 is what? 2. So you will get 2 here. Right? Now come to this one. R1 that is 0 minus 1 by 3 into R2 is 3. 3 will get cancelled. 0 minus 1 is what? Minus 1. You will get minus 1. Okay. Into A. No change in R2. So all R2 elements you write as it is here. Okay. 0, 1, minus 5, 3. See, when I started this question, what I said in the beginning, our intention is we want to convert this matrix into unit matrix. You observe at the end, we got 1, 0, 0, 1 unit matrix. Once you got this step, this problem is over. What we'll write here, whatever you got this is inverse of the matrix as per the definition of inverse of a matrix. What is A inverse? A inverse is 2, minus 1, minus 5, 3. So for the given matrix, inverse is this matrix. I hope you understand. These problems are little difficult only, but with practice you can do these things very easily. Now we will see one more problem of same type. We need to find inverse of this matrix by using elementary transformations. What is the first step? First step is which matrix inverse you want to find. You take that matrix as A. So what is A? Given matrix 3, minus 1, minus 4, 2. Okay. Now you want to find inverse of this matrix by using elementary transformations. Okay. What is the first step? First step is, I'll write like this. A equal to I into A. What is A? A is given matrix 3, minus 1, minus 4, 2 equal to I. I means identity matrix 1, 0, 0, 1 into A. Now what is the basic idea? This is the first problem, fourth problem in this exercise. Na? By this time you got an idea. You want to convert this into identity matrix 1, 0, 0, 1. For that you want to follow that U rule. U rule is nothing but first we'll observe at this part. If 1 is there, we'll move to this part. If 0 is there, then we'll move to this part. And if 1 is there, then we'll move to this part. If these things, if this is not 1, we'll make 1 and we'll move to this place. If this is not 0, we'll make this 0 and we'll come to this place. If this is not 1, we'll make 1 and we'll move to this place and we'll make this element 0. Right? So basic idea is I want to convert this matrix into unit matrix by using elementary transformation. You observe here, now you are at this place 1. We want 1 at this place. Look here, we want 1 at this place. How to get 1 at this place? Very simple. I'll multiply with 1 by 3. 1 by 3 into 3 is what? 3 will get cancelled 1. So to get 1, this is in first row now. All the elements of first row I'll multiply with 1 by 3. Another operations also you can use, but I felt that this is the easiest operation. R1 changes as 1 by 3 into R1. To get 1 at this place, I am multiplying all the elements of first row with 1 by 3. That's why I used this operation. Okay. Now R1 changes. All the elements of first row you multiply with 1 by 3. Yes. 1 by 3 into 3 is what? 1. Okay. 1 by 3 into minus 1 is what? That is minus 1 by 3. Okay. Equal to 1 by 3 into 1, that is 1 by 3. Okay. 1 by 3 into 0, that is 0. Right. Into A. So all the elements of R1 multiplied with 1 by 3. Now R2 as it is. All the elements of R2 you write as it is here. Okay. Minus 4, 2, 0, 1. Now you want to convert this into unit matrix. Now you want 1 at this place. We got 1. Once this work is over, you just move to this place. Right? Here work is over. You move to this place. You want 0 at this place. We can make this 0 very easily with the help of this one. Here minus 4 is there. Na? If plus 4 is there here, it is very easy. Minus 4 plus 4 is 0. You want to get 0 at this part now. So we can make this 0 very easily. With the help of this one. This is in second row. Okay. R2 changes as what you written here. Same thing you write. Okay. R2. I'll use plus. Here minus 4 is there. Na? Here I want plus 4. Minus 4 plus 4. R2 plus. I want 4 here. How I'll get 4? If I multiply this row with 4, I'll get 4 times of R1. Why I written this operation? To get 0. If I write this operation, then only I'll get 0. R2 is minus 4. Minus 4 plus 4 into 1. Right? So, right. Okay. We'll use this operation. Let's see what we'll get in second row. Okay. First row. 1 minus 1 by 3. No change in first row. Change is there only in second row. 1 by 3. 0 A. Right. Now R2 plus 4 times of R1, that is minus 4 plus 4 into 1. Minus 4 plus 4 is what? That is 0. Now come to this element. R2 2 plus 4 times of R1, that is minus 1 by 3. That is 2 minus 4 by 3. So if you simplify this, 6 minus 4 by 3. 6 minus 4 is what? 2 by 3. So if you use this operation, you will get 2 by 3 at this place. Okay. This is 2 by 3. Now, yes, come to this part. Right. 0 plus 4 times of R1. In R1, 1 by 3 is there. So this is 4 by 3. Right. This is 4 by 3. Okay. Next, R2. You come to this element. 1 plus 4 times of R1. 0 is there. Right. 1 minute. 1 plus 4 times of 0, that is 1. Okay, you will get 1 here. Now you want to convert this matrix into unit matrix. Now at this place you got 0. Here work is over. So you come to this part. You want 1 at this place. How to get 1 at this place? Here 2 by 3 is there. Na? I'll multiply with 3 by 2. 2 will get cancelled. 3 will get cancelled. We'll get 1. So all the elements of second row I'll multiply with 3 by 2. Why? Basic idea is I want 1 at this place. So R2, I'll multiply all the elements of R2 with 3 by 2. Let's see what you will get. R1 is as it is 1 minus 1 by 3. Okay. 1 by 3 0. Okay, into A. All the elements of R2 you multiply with 3 by 2. 3 by 2 into 0, that is 0 only. Okay. Now 3 by 2 into 2 by 3. 3 by 2 into 2 by 3 is 1. Right? It is 1. Okay. Now 3 by 2 into 4 by 3. 3 will get cancelled. So what you will get, 3 by 2 into 4 by 3 is 2. Okay, 2. Now 3 by 2 into 1, that is 3 by 2. Okay, now you can observe here, we want to get 1 at this spot, we got 1. So work is completed here. Now come back to this place. Now you need 0 at this part, you want 0 at this part. We can make this 0 very easily with the help of 1, with the help of this one. Here minus 1 by 3 is there, na? You want plus 1 by 3, minus 1 by 3 plus 1 by 3, then it will become 0. So I'll use this operation to get 0 at this part. R1 changes as R1 plus, R1 means this element, R1 changes as R1 plus, I want 1 by 3, minus 1 by 3 plus 1 by 3. So 1 by 3 into R2. Okay, use this operation R1, 1 minus 1 by 3, okay, equal to, R1 changes there, no, 1 minute, R1 changes there. R1 changes as 1, R1 is 1, R1 is 1, 1 plus 1 by 3 into R2 is 0. So what you will get, that is 1 only, 1. Now this element, minus 1 by 3 plus 1 by 3 into R2, 1 is there. Minus 1 by 3 plus 1 by 3 is what? It is 0. Okay, you will get 0 here. Now come to this element R1. R1 is 1 by 3. 1 by 3 plus 1 by 3 into R2. R2 is 2. So what is this? 1 by 3 plus 2 by 3. That is 3 by 3. 3 by 3 is 1. So you will get 1 at this place. 1. Okay. Now come to this element. 0 plus 1 by 3 into R2. That is 3 by 2. This 3 will get cancelled. You will get 1 by 2. So this is 1 by 2. Now second row, I'll write. Second row is as it is. Okay. I'll write second row as it is 0, 1, 2, 3 by 2. Now you see here, I converted this into unit matrix. Basic idea is what? You want to convert this matrix into unit matrix 1, 0, 0, 1. Now you see, you got 1, 0, 0, 1, right? So once you got 1, 0, 0, 1 here, we know that whatever answer is there here, whatever is matrix is there here, that is inverse of the given matrix. What is A inverse? 1, 1 by 2, 2, 3 by 2. This is inverse of the given matrix. Now we need to find inverse of this matrix by using elementary transformation. You can observe in all the problems, if they are asking find the inverse of the matrix if it exists. So this is the problem. For this matrix, inverse does not exist actually. Why inverse does not exist? When we will come to know that inverse does not exist, all those things we will learn now. First thing, I'll take given matrix as A. Procedure is as usual. You start with the as usual procedure. What is matrix A? Given matrix 6, minus 3, minus 2, 1. Now first step is what? We will write A equal to I into A. What is matrix A? 6, minus 3, minus 2, 1. Okay. Identity matrix. What is identity matrix? 1, 0, 0, 1. And you write A. What is the basic idea to find inverse of matrix? You want to convert this into identity matrix like 1, 0, 0, 1. You want 1 at this place. So you want 1 at this place. To get 1, what I'll do? Here 6 is there, na? I'll multiply with 1 by 6. So that 6 will get cancelled. I'll get 1. So basic idea is all the elements of R1 I'll multiply with 1 by 6. You can understand by this time because this is the fifth problem we are doing in this model. All the elements of first row you multiply with 1 by 6. What you will get? 1 minus 3 into 1 by 6. That is minus 1 by 2. Minus 1 by 2. Okay. 1 by 6 into 1. That is 1 by 6. 0 into 1 by 6 is 0. All the elements of first row I multiplied with 1 by 6. Now all the elements of second row you write as it is. Minus 2, 1, 0, 1. Okay. Now once I got 1 here, now come to this place. You want 0 here because you want to get this matrix. Now you want 0 at this place. We can get 0 very easily when you see 1 here. We can make this element 0 very easily by using this 1 with the help of elementary transformation. How? Here minus 2 is there. Na? If plus 2 is there, I'll get 0. So what I'll do here, this is in second row. I'll use this operation. R2 changes as what you written here, same thing you write. R2 plus minus 2. I want plus 2 now here. So how I'll get 2 here? Multiply this row with 2, right? 2 times of R1. If I use this operation, then only I'll get 0. I want to get 0 here, right? Okay. 1 minus 1 by 2. No change in R1. So that's why I'm writing R1 as it is. 1 by 6, 0 into A. Change is there only in R2. R2 plus 2R1. R2 means minus 2 plus 2 times of R1. R1 is 1 is there. So this is 0. So to get 0, we written this operation. Now come to this element R2, that is 1 plus 2 times of R1. R1 is minus 1 by 2. Minus 1 by 2. So plus 2 minus 2 will get cancelled, right? Plus 2 minus 2 will get cancelled. 1 minus 1 is 0. You are getting 0 here. Okay. Now come to this R2. 0 plus 2 times of R1. R1 is 1 by 6. So here what you will get, 0 plus 1 by 3 is 1 by 3. Okay. Now come to this one, R2, that is 1 plus 2 times of R1, 0, that is 1. Okay. So what happened here, you can observe in the left hand side, all the elements of second row are 0. Whenever you see all the entries of any row in the left hand side is 0, that is the indication that inverse of a matrix does not exist. You will learn more clearly about inverse of a matrix in determinant chapter, but in this chapter this knowledge is enough. While finding inverse of a matrix by using elementary row operation, if all the elements of any row are 0, then what we say? We say that inverse of a matrix does not exist. Whenever you got something like this, all the elements of second row in the left hand side are 0. Therefore, we say A inverse does not exist, right? So in this way, we will say that inverse of a matrix does not exist, right? So you learn how to calculate inverse of 2 by 2 matrix by using elementary transformations.